Assalamualaikum warahmatullahi wabarakatuh. Did you guys know that waste management is one of the global issues that need to be taken care of? Since every year, amount of waste produced by every sector, including industrial waste and food waste, keep on increasing. Improper waste management can lead to the environmental issue like air pollution. So today we will be discussing about a biotechnology method that can help to convert the waste into functional product, which is hydrothermal carbonization of sewage sludge, hydrochar properties, and wastewater treatment by distillation and wet oxidation. In this article, the authors mainly discussing about two research problems, which is the first one is the optimal operating condition for the hydrothermal carbonization process, since they need to find out the best condition that can produce the best quality of hydrochar fuel. The second one is about the post-treatment method for the toxic liquid byproduct that was produced from the HTC process. The author proposed two methods, which is the wet oxidation and distillation. So they need to find out which one is the best method. This study is very important since we can see the demand for sustainable waste management and sustainable resource recovery. The second one is this study is highlighting about the innovative use of hydrothermal carbonization process, as we can see where the hydrothermal carbonization process can turn the sewage sludge to the functional product, which is the hydrochar fuel. And the last one, this article also provide the method to purify the toxic liquid byproduct from HTC.
Hi, now I'll be explaining the overview of the methods that the writer of this article used. There are five methods that has been used in this research. The study began by collecting dewatered sewage sludge from a municipal wastewater plant in Lubin, Holland. Then the sludge was stored at 4 degrees Celsius to slow biodegradation before processing, which is a very crucial first step to maintain material integrity. For hydrothermal carbonization, HTC, raw sludge was diluted to 90% concentration and processed in a 1000 milliliter steel reactor at either 200 degrees Celsius or 220 degrees Celsius for 2 hours. This produced two outputs, which are solid hydrocar and liquid filtrates, which were separated for further analysis. So the hydrocar underwent comprehensive analysis, including proximate and ultimate analysis and higher heating value (HHV) determination using a LICO calorimeter. SEM, EDS, and XRF analysis provided detailed structural and elemental composition data. Next is additional characterization included FTIR spectroscopy for chemical bond analysis, thermogravimetric analysis for combustion performance up to 900 degrees Celsius, and BET surface area measurement, though results showed surprisingly low porosity. Now, we are going to talk about the fourth method has been used in this research, which is processing water treatment. So the liquid byproduct was treated to waste, which is distillation under low pressure spirited 90% clear liquid from 10% residue, while wet oxidation used high pressure oxygen at 240 degrees Celsius. Both aim to reduce organic pollutants measured by carbon oxygen demand COD. So these are the key techniques that has been used in this research, which is including hydrothermal carbonization, HTC, XRF analysis, specific surface area determination, FTIR analysis, and many more. There are two approaches for treating liquid from the HTC process, including distillation and wet oxidation. This study also detects several limitations, including complex heavy metal migration mechanism. During HTC, need further study, and wet oxidation requires process optimization. Additionally, hydrocar's low surface area and slagging tendencies present challenges. First is hydrothermal carbonization, HTC, improve fuel properties. HTC significantly improved fuel properties. Fixed carbon increased from 10.76% to 12.93%, while heating value rise from 17.71 to 19.04, as you guys can see in table 1. Notably, sulfur and nitrogen content decreased, reducing potential harmful emission. For the distillation, effectively reduce COD in processing water. Distillation excel, reducing COD from 45,900 to just 1,430 milligram oxygen per liter, which is a 97% reduction. However, mercury levels unexpectedly increased in distillates, possibly due to evaporation, contrasting with other heavy metals that were effectively removed, as you guys can see in table 7 attached on the slides. For the last key results, which is wet oxidation less efficient than distillation for COD reduction, wet oxidation was less efficient, achieving only 60% COD reduction to 18,200 milligram oxygen per liter. While it showed some promise, the process clearly underperformed compared to distillation and requires optimization, as I mentioned before. So as you guys can see here on this slide, all 8 results are compared to another study and it is aligned. There are 4 surprising outcomes, including heavy metal increases in distillation, wet oxidation efficiency compared to distillation, and then the high slagging tendency, and the last one is the specific surface area.
Let me walk you through the key discussion points from the study. First, the author interpreted that hydrothermal carbonization significantly improved sewage sludge. It increased carbon content and calorific value, making hydrocar more energy dense and easier to dewater. However, there's a drawback. The resulting ash possesses a medium to high risk of slagging and contamination, which could hinder clean combustion. For liquid byproduct, distillation dramatically outperformed wet oxidation in treating toxic compound, reducing chemical oxygen demand by up to 32 times. From a theoretical standpoint, these studies support the classification of hydrocar as a fuel comparable to lignite, advancing research on waste to energy pathway. It also reinforced HTC efficiency advantage over traditional drying or incineration method. However, the combustion behavior of hydrocar ash introduced new challenges, especially for industrial application. In terms of practical application, hydrocar can serve as a solid fuel or fertilizer, and the treated water, especially after distillation, is safe enough for reuse or safe discharge. These make HTC highly relevant for municipal wastewater management, where sludge treatment and cost efficiency are top priority. Finally, for future research, the study suggests optimizing the wet oxidation process to improve energy recovery. It also highlights the importance of understanding heavy metal migration and immobilization during HTC and reducing the slagging tendency of hydrocar ash to enhance its combustion quality. Thank you.
Next, I will talk about the critical analysis of this article. The strength of of the article is it provides a comprehensive study since it covers both solid and liquid phase of the HTC process. The hydrogen fuel is the solid phase and the toxic liquid byproduct is the liquid phase. Next, it also provides comparative insight since it tests two possible post-treatment methods to treat the toxic liquid byproduct, which is the wet oxidation method and the distillation method. And lastly, it also uses robust mix of methods such as FTIR and TGA, which make the result is more reliable. As for the limitation, the study only used narrow temperature range for the HTC, which is 200 and 220 degrees Celsius, and also they only provide limited wet oxidation data, which will result in underestimated of their true potential. Lastly, the study also conducted under lab scale only, which will not properly illustrate the challenges in real industrial condition. As the alternative interpretation of data, wet oxidation might also be a good choice for the post-treatment, but further optimization need to be done onto the method since in this study, the wet oxidation method was just a preliminary study only. In conclusion, HTC is a promising waste to energy solution for the growing challenges of sewage sludge management. It produces a solid fuel called hydrochar with improved energy properties without the need for costly drying. And distillation has been identified as the best way to purify toxic liquid byproduct from HTC compared to wet oxidation. Further study can be done on HTC process in order to reveal its true potential to recover clean energy, nutrients, and valuable byproduct from waste stream. As example, the production of lipid extracted hydrochar from algae using HTC process. This highlight the role of HTC in waste management, renewable energy, and environmental technology.